Good morning. I am Mrs. Saxila Jovita, Assistant Professor, KCS Kasinagar College of Arts and Science. In this video, we are going to discuss about tree and nonlinear data structure. And the topics which we are going to cover are trees, representation of trees, and about the terminologies in trees. Tree definition. A tree can be defined as a finite set of data items called nodes. Tree is a nonlinear type of data structure in which data items are arranged in a sorted sequence. Trees represent the hierarchical relation between the various elements. A tree always grows in length towards the bottom in the tree data structure. Representation of tree. As other data structure, we used to represent tree data structures also in two ways. First is linked list and the second one is sequential memory representation, that is the array format. Here we are discussing about the linked list representation. So we are splitting our memory in three sequence array format. One is to contain information, and the another one is to hold the left node, and the another one is the right node. Okay, then first you are going to take this C. Using this diagram we are taking the node C. So in that information we are having C, and in the left node we are representing it as 0 because this C node does not contain the left node, it holding only the right child. So in the leftmost position we are marking it as 0, and right side we are marking it as 10. So if it is 10 means we are going to the address 10, and we are searching the information and scanning the information as F. So this F will be the right child of that C, and in this right side node the address of this F is represented. Okay, and then we are moving to D. Okay, in that D, how many nodes are there? No, the D holds no nodes. That means right side also null and the left side also null for this D node. Okay, and the information holds D, and the right node holds 0 as well as the left also holds 0 because there is no node further in D node. And after that we are moving to E. In information box we are scanning that E, and again we are checking for the right node and left node, the same as D, E also not containing 0 left node as well as the right node. So we are marking it as 0 0. And next moving to A. So A holds as 7th left side is 7. So again we are moving to the 7th address, and we are finding that B is the left child of that A. Is it correct? Yes. And then we are moving to that right child, and here it is 1. So we are moving to 1, and there we are finding that C is the right child of the A. Yes, A holds B as left child and C as right child. So we are presenting the address of that particular node in that right and left array format. Okay, so this is how we are representing the tree data and its left node right node details in linked list. Representation of battery in sequential representation. So tree nodes are stored in linear data structure like array. Root node is stored at the index 0, and if the node is at the location I, then the right child is located at 2 star I plus 1, and left child is located at 2 star I plus 1, and the right child is located at 2 star I plus 2. So let us take an example. See here the root node is A, and the index value of that root node must be 0 as per rule. Okay, so in 0th position we are having a root node A. Now we have to find the left child of the we have to find the location of the left child of that A and right child of that A. Okay, to fix that left child we have to use this formula 2 star I plus 1. Now the I value is 0 because A is at the position 0. The I value is 0. Okay, the left child should be stored at 2 star 0 plus 1th location. That is 2 star 0 means 0 plus 1 is 1. So at the position 1, the left child of the A should be stored. So the left child is B now. So B should be stored at the position 1 in our array. Okay, and after that we can calculate the right child location. Okay, for that A doesn't have any right child. Okay, so after that we have to find that location going to node B. B doesn't have left child and it is having right child. So we want to calculate the position of that C. Okay, for that we are moving be it at the position 1 now. Okay, be it at the position 1 and our I is 1 now, right now. Okay, so 2 star 1 is 2 and 2 plus 2 which gives the location is equal to 4 and C is the right child of the B node, that is C, should be stored at the array location 4. This is how we are finding the location for the left child as well as the right child. If there is no right child, the cell is empty. We are leaving that cell as empty. Okay. This is how we are representing the elements in a tree in array format, that is sequential representation. Next, terminologies in tree. The first term is root. What is root? A node at the top of the tree is called root. There is the only one root node per tree. Okay, and the root node of the tree has its children. In the figure, A is the root node. Okay. Next term is degree of the node. What is the degree of the node? The total number of child attached to that node is called the degree of the node. So let us see in our diagram. Here, take that node A, and A contains B as a child, C as a child, and D as a child. So A contains 3 child. A has 3 child. So degree of that node A is 3. Okay, and D, here let us take D now. D contains 1 child and degree of that node D is 1. And take that node E. E has no child. So the degree of that E is 0. Clear? Next term is leaf node. Leaf node are the terminal nodes of the tree. The node which have, in other words, we can say the node which have degree 0 are called as leaf node of the tree. These nodes are always present at the end of the tree. So in our example, E, F, G, C, H or all are leaf nodes. Okay. Next term is internal nodes. The nodes in the tree which are other than leaf nodes are called internal nodes. These nodes are present in between root node and the leaf nodes are called as internal nodes. In our diagram, B, D are the internal nodes and it includes root node also. Next term is parent node. The node which is having further sub branches is called the parent node of those sub branches. So in our diagram, B is the parent node of E, F and G, and E, F, G are the children of B. Okay, and also B, C, D are the children of A, and A is the parent node of B, C and D. Next is siblings. Nodes with the same parent are called siblings. Here B, C, D are siblings of A. Next, level of trees. The root is always considered at level 0 and then its adjacent children are supported to be at level 1 and so on. So here the root node is at level 0. Then the adjacent children B, C, D are at level next, that is level 1, and E, F, G, H are at level 2. Here we are representing the tree hierarchical at levels. So this is the level of the tree. Next is height of the tree. The maximum level is the height of the tree. Here the level height of the tree is 3 because the maximum level is 3, 0, 1, 2. So total number of level is 3. The height of the tree is 3. In other term we can say this height as depth of the tree also. The depth of the tree is 3 here. Next, degree of the tree. The maximum degree of the node is that in the tree is called degree of the tree. Here the degree of the tree is 3. The maximum degree of the node. Here node A's degree is 3. 1, 2, 3. And node B's degree is 3 because it's holding 3 child. So 3. So the D's node is 1. So here the maximum number of degree node is 3. So we are saying that degree of the tree is also 3. Next term is forest. An arbitrary set of the tree which is called a forest. In simple term we can say forest consists of collection of trees. So here is a single tree and we are splitting it and we are having the collection of trees here. So these can be called as forest. The last term which is binary tree. This is a very important concept in trees. So what is binary tree? A tree data structure in which each node has at most 2 child node is called a binary tree. So in other words, a binary tree is a finite set of nodes that is either empty or consists a root node and two distinct binary trees called left subtrees and right subtrees are it is denoted as binary tree. So the main important point is binary should hold at most 2 children. That means it can have 0, 1 and 2 as a child. Okay, in next video we can discuss about the types of the binary tree and its properties, advantages. Thank you.